Well, hello again everyone. Welcome back to our third video in the unit on geometry for grade 8. Today you can see I've got a few triangles drawn here and we're going to take a look at them once again. I'd encourage you to remember when we cut out a triangle and we tore off each of the vertices and we placed them on the paper and we noticed they all came out to a straight line. If you check out the Explore, which is on page 278 in the textbook, they invite you to try that exercise, and I think it's a great idea to do it and just see for yourself that it always comes out to a straight line and all the angles in a triangle add to 180 degrees. Now, since we know that, here's a triangle WAY, where we have one angle 78, the other 40, and knowing what we know about the angles in a triangle, we can work out what angle WAY has to be. So if you take a minute to think about how you might do that, some of you have probably guessed it already. We're going to figure out what these two add up to and then subtract that from what we know they all have to add up to, which is 180 degrees. So let's take our 78 degrees and our 40 degrees. We'll add those up and that'll give us 118 degrees. That's the combined total of these two, and then we'll take that amount and we'll subtract that from 180, which is what all of the angles in a triangle should add up to, and that will leave us with 62 degrees. And so now we know that this angle is 62 degrees. And just to show our math thinking, we can say, okay, angle WAY equals 62 degrees. And we know that because of, and again, short forms are always kind of helpful for this sort of thing, angles in a triangle. Now you can write out the sentence, no problem, angles in a triangle. But if you just use that little bent L to symbolize an angle, then we have angles in a triangle. A nice little short form for that. It still shows your thinking. We have another example of a triangle over here, triangle HIP. And if you were observant, you might have noticed there's a tick mark on each of these lines, and you might recall that means this line has exactly the same measure as that line. And so this is an isosceles triangle. And the neat thing about an isosceles triangle is that the angles formed at the bottom of these two lines that are the same measure, these two angles at the bottom also have the same measure. So now we know that angle IPH is 68 degrees. So we can write that by saying, okay, angle IPH equals 68 degrees, and that's simply because we have an isosceles triangle. So we've shown that. And now I think most of you know exactly how we're going to get that guy. That's right, we're going to add these two then subtract them from the 180. And if I add these two guys together, I get 136 degrees. If I subtract that from 180, I'm left with 44 degrees. And so I can say angle IHP equals 44 degrees. And again, that is because of angles in a triangle. Now, one more small thing that might come up here and there is understanding what all the angles in a quadrilateral add up to. You might recall that a quadrilateral is basically any four-sided polygon. So that's a quadrilateral. And the way to know almost instantly what do all, well, I guess if I told you all angles in a quadrilateral add up to the same thing, no matter the quadrilateral, then you might remember this, one of the most simple regular quadrilaterals, the square. And you know that the measures in each corner of a square is 90. If we add those up, we do get 360. And so there you have it. If you were to measure all the angles in this quadrilateral, they would also add up to 360 degrees. So there you have it. Four-sided polygons, angles add to 360. Three-sided polygons, angles add to half of that, 180. Okay, thanks for listening, everyone. Do check on Classroom for your assignment for today, and I wish you the very best with it. And you see, it's just that easy.